Let us look at proposition number 39 of Works of Archimedes, specifically from book 1 of On the Sphere and Cylinder. The proposition says the surface of the solid figure circumscribed about the sector of the sphere, excluding its base, will be greater than that of the segment of the sphere whose base is the circle on the base of the segment of the sphere. So let's take it step by step and understand what is happening here. Let L, A, L prime, lowercase, be a segment of a great circle of a sphere less than a semicircle. Let O be the center of the sphere. Let me just show you the sphere. Join OL and OL prime, and let's join OA as well. Now circumscribe a polygon about the sector O, lowercase l, lowercase a, lowercase l prime, such that its sides are 2n in number and all are equal. Of course, these two radii that we have, that we exclude. Circumscribe a segment of a circle, capital L, A, L prime, about the polygon with capital A as the midpoint of the segment. So let's circumscribe a segment of a circle. Let A be the intersection point of the great circle with OA. The inner circle is the great circle of this sphere. Now both circles will have the same center O. Revolve LAL prime, LAL prime, both the inner segment of the circle and the outer segment of the circle, along with the polygon about OA. So let me demonstrate this to you. So, all the three are in different colors. So let's see what's happening here. The two arcs, that is capital LAL prime and lowercase LAL prime, will describe the segments of the sphere. The angular points B prime and LL prime, capital LL prime, will describe circles with diameters B prime and LL prime on the outer sphere. Points of contact between the polygon and the inner circle will describe circles on the inner sphere. The sides of the polygon will describe the surfaces of the cone and frusta of cones. All this we have seen in previous propositions. Now the surface formed by the revolution of the sides of the polygon will have as its base the circle of diameter caps LL prime. Now draw tangents at LL prime lowercase intersecting the sides of the polygon at T prime. Now if I draw it, it will not be visible, so let's get rid of this. Okay, now let's draw those tangents at lowercase l and L prime, and the intersection with the sides of the polygon, we'll mark it as T prime. So we have this line, and let's mark this point as T. Now it may look as if it is on the circle, but this point T is not on the circle, because remember this lowercase lt is a tangent at L. So that's the only point of contact with the circle that it has. Similarly, we will have on this side as well. Now we revolve the polygon small l T B A B prime T prime small l prime about OA. So let me again demonstrate that. Now surface of the solid described is greater than the surface of the segment of the sphere. That is the inner sphere, the given sphere. Why? Surface described by capital LT is greater than that by small lt, since angle TLL is equal to 90 degree, which implies that it's a right angle. That means LT square is equal to small lt square plus L square. So that means capital LT is greater than small lt. So that's how we can say surface described by LT is greater than that described by small lt. So therefore, surface of the solid described by the polygon capital L, T, B, A, B prime, T prime, capital L prime is greater than the surface described by the segment of the great circle. So, here, if you notice, he really didn't bother about all the other places. He just showed that the circumscribed solid will be greater than the sector of the sphere by just looking at these 2 points. That is more than enough to prove the proposition. So that is proposition number 39 of book 1 of On the Sphere and Cylinder. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.